Okay, this video is for a friend of mine, and he tried to do some mixture adjustment on this old Mercedes, and they got into trouble. So here I am looking at it, and when it came in, the O2 sensor wire, which is the one you see right here, it was all chewed up. All those little bits of copper strands that are down there, those were all kind of just tangled all up all over that wire. Now, I like to use a piercing probe under certain conditions and situations. This wire is inside the passenger compartment. It's not exposed to a lot of road salt or road moisture, but even so, if you can, it'd be a good idea to go ahead and put a little silicone over the top of the wire wherever you pierced it. So you see there's my piercing probe, and that's my O2 sensor pattern. If you probe it here, there's no danger of shorting anything out in any way. But on this side is much fatter because it's a shielded wire. The outside fatter insulation surrounds the shielding wire, and it's basically a web of wires all the way around to keep interference from getting into the O2 sensor signal all the way back down to the computer. So if you go to the computer side, this fat wire would reach the computer. That shielding is grounded. So if you try to pierce right here where somebody else did, what you're going to do is you're going to short the shielding cable into the O2 sensor conductor. So all you're going to do is short the signal. It's not going to run right, and you're not going to get an accurate signal. And in this case, it was so tangled up that there are several cuts in the wire. The shielding was actually touching the O2 sensor signal wire, so it was basically shorting out the signal all the time. So once I got all that stranded wire cleaned out, I went ahead and pierced up here, and but you could pierce now. In this case, you can pierce on either side. You can pierce over here without any problems because it's no longer got shielding wire all over it. So you can see right there, I used an existing hole, and there's my pattern. Okay. So now I'm going to show you where the adjustment is. Okay, so now you can see that signal there, that pattern right there. When I first got to it, after I had a good connection for the pattern, it was all the way down at the bottom at 0, and it was there because it was adjusted too lean. Right in here is your adjustment. It's adjusted right through the top of here. In this particular case, because this is a downdraft airflow meter, to richen it, you go in. Unlike a carburetor, in most cases, when you go in, you lean it. In this case, when you turn the screw in, it richens it. So I'm going to back it off and make it leaner, and then we'll look at our pattern. See, now I made it leaner, and now you can see the pattern is stuck at the bottom. It's out of adjustment range for the computer. Now I'm going to richen it by turning it in. Just small movements. You can see now it's at the top. So now the computer is going to take a minute and start adjusting lean. But now it's in adjustment range for the computer, and you can see now it's taken over, and it goes rich, lean, rich, lean, rich, lean, which is normal. That's what you want to see. I'm going to give it a little bit of gas and see if it stays switching. Now that rich lean switch, that's what you want. Okay, so you just basically turn it to small increments until you get a rich lean switch at idle and a rich lean switch at 2000 RPM or 2500 RPM. Okay, that's about it.